Do this. Okay, so we are in homework 4 content. Yay. So we talked about everything with homework 3. I've actually been done with homework 3 content for a week, and we went, did examples of different things last week. So homework 3, if there are questions about it, I'll still answer them as always. But homework 3 content's done. It's all in your hands. A lot of you probably have the expected deadline by now, have submitted and got the learning objectives at least. Yeah, homework 3 is done. I'm on to homework 4 content. So let's talk about homework 4. Who's ready? So for homework 4, the first learning objective is kind of a warm-up one and something that, honestly, in the future, this will be a topic much earlier in future 312s. But we need cookies because our ultimate goal is authentication at this point. We're going to need cookies for that. So building a simple visit counting cookie to be able to just get some practice with cookies before diving into full authentication. So visit counting cookie, every time somebody reloads your page, if somebody goes to your page and hits refresh a bunch of times, they should have something on the page that says you visited this page this many times. So nothing too wild, but we do need to learn today's concept of cookies to be able to do this one. And after today, you'll be able to do learning objective 1. You'll have everything you need to do this cookie, this visit counting cookie. Actually displaying the cookie on the page, you have your HTML templates. We've been doing that for quite a while now. And you'll have to read the cookie to be able to get that counter for each person. And this should be individual to each user. If you have one browser open with a certain value for that visit counter, you should be able to open a different browser, not a new tab in the same browser, but a different browser, importantly, to be able and have that counter be different for that user, for that visitor. Different browser. When I say different browser, so browser, tab, window, I don't use those different terms lately. That those do mean different things. If I say a new browser window versus a new browser tab versus a new browser, those are all different things. So this means like use Firefox and Chrome, for example. Use two different browsers. I thought that was. I was going to message you. I forgot. So this has to be a separate browser, a completely separate browser, because each browser is going to keep track of your cookies, and it won't work if you close the browser and reopen it. If it's the same browser, it's Firefox both times. That cookie's not being reset. So separate browser to make sure it works with separate users. Yeah.
If you incognito mode, does each tab have its own cookie?
Oh, yeah. Or use incognito mode. I'm 98% sure. I should test that again just to make sure. But if you open up a new incognito window, then it won't share cookies with your main window. So you could do that as well to test this. But any way to do this where the two loading the page two separate times isn't sharing the same cookie. Learning objective 2, authentication and tokens, and this is the bulk of the homework for a lot of the assignments. Like AO3 has been the hard one. I don't think that's the case here. Of course, somebody's going to disagree with me at the end of it all. But I don't think AO3 is very hard. I don't think AO2 and 1 are all that hard either. And this one, learning objective 2, is where the bulk of it is, which is kind of the nature of authentication. I couldn't really come up with too much without just being complex for the sake of being complex to add after you have authentication. And I need everybody getting practice with authentication itself. So authentication, learning objective 2, this is the big one for this assignment. That said, I think it's easier than either, I've said this before, but it's definitely true now that homework 4 is out and I know what changes I'm making from last semester, which ended up being 0. I didn't change this at all from last semester, for anyone wondering. But I still think that this is a lot easier than homework 2 or homework 3. But this is the bulk of this assignment, is learning objective 2. So authentication with tokens, starting on Wednesday, we're going to learn how to do all this stuff. is have a registration form and a login form. Users can register for an account using a username, providing a username and a password, and then they can log in using that same username and password. The big thing here is securely storing the passwords. We're never storing a password as plain text. We're always going to store a salted hash of the password when we're storing a user's password. And then we're going to issue a token. When they do log in, we're going to issue them a token, a secure token, and as a cookie. And then whenever we see that cookie come back that has that same token value, we're going to treat that user as authenticated, as them, as that person that's authenticated as that. And all that stuff has to be in your database. The authentication tokens, the usernames, the salted and hashed passwords, all that information must persist. Once you have users who are logged in, you have some freedom in how to do this. You have some chat feature on your app that must be authenticated, where users can only send messages if they're logged in. And when they're logged in and they send a message, their username should be displayed next to that message. So in Homework 3, we just had randomly generated usernames, and it got us to be able to work with WebSockets, but it didn't really make sense. You're not just going to have random usernames. And we had the chance of username collision and things like that. Here we have authentication. We're building authentication, and we're going to make sure that when somebody chats, it actually has their username next to it, and we can verify that it was them. Other users can say, yeah, they must have authenticated as that user if their name is next to that message. Actually, I think I forgot to update it. Maybe I have it in here. But if I don't, it's not that big of a deal. It doesn't change the educational value. But I meant to add a line that said if somebody tries to register an account for a username that's already been taken, that wouldn't be allowed. But I think I forgot to, which it's released now, so I'm not going back and changing it. I don't change assignments after they're released to you. Somebody might have seen this morning and already started. I'm not gonna change it now. But yeah, it looks like I forgot to add that in here. Oh, and their username should be displayed on the page somewhere. When they're logged in, their username should be somewhere on the page. It's up to you on how to do that, but it should be somewhere. And once you have, for application objective 2, you have choices in how to build the chat. So if you have your chat using WebSockets from Homework 3, if that's working and you're happy with it and it's robust and everything, which it should be because it's a learning objective, but maybe you can't handle large messages if you didn't get AO1. But you can use that for WebSockets. You would authenticate during the handshake, and then instead of having their random username, you would actually load their actual username during the handshake, and then every message that they send over the WebSocket, you would treat that as authenticated because the handshake was authenticated. But we don't have a great way of authenticating every single WebSocket message that's sent. Or you can go back to, you can do AJAX and polling. You can go back to a multi-part form like Homework 2. You're welcome to do whatever you want for this chat, however you want to build it. I think the easiest one might be just using your Homework 3 code because you already built a whole chat app for that one. You already have all the functionality, but you do have to authenticate during the WebSocket handshake. That's your only chance to authenticate is during the handshake, unless you build something kind of janky by sending WebSocket messages to authenticate. But once it's authenticated, you can assume that connection is authenticated throughout the entire lifetime of the WebSocket. And then authenticated cross-site request forgery tokens. So we built cross-site request forgery tokens in Homework 2. And at that time, I said it doesn't really make sense because the attacker can visit your page, get a valid token, and then use that valid token for their attack. We're going to get rid of that vulnerability by authenticating our cross-site request forgery tokens now. So when you issue a cross-site request forgery token, you're going to associate that token with the account that requested the token. So somebody visits your page, you check their auth token, they're authenticated as a particular person. You're going to generate a cross-site request forgery token for that user, store that token in your database for that user, associated with that user, and then send them that cross-site request forgery token. And when they send a request, that token that they send, you're not only matching their authentication token, but also matching their cross-site request forgery token to make sure that both tokens match. And if both do and are both associated with that account, then you can say, okay, this is the person, this is all legit. This one breaks down a little bit with WebSockets. So you have to figure out some way to do this with WebSockets. This was a big question last time of how to do the cross-site request forgery tokens with WebSockets. I'd say send it on each WebSocket message. If you're doing that, that would suffice for me. Every time they send a WebSocket message, attach the token in that JSON that you're sending and say, hey, here's my cross-site request forgery token. And then that should be good. It's a little awkward with WebSockets because it doesn't 100% make sense, but you're not going to have that token during the WebSocket handshake, so you don't have a chance to verify it then. So we have to do something to still authenticate that, to still verify that. This is more designed with AJAX in mind. But I suspect quite a few of you will do WebSockets instead of AJAX. And then the last one, HTTPS, the very last objective of the course. We're finally going to get to HTTPS. I kind of demoed this in a way last week. I did deploy an app with HTTPS, but that'll be quite a bit different than the way you'll do it on the homework. Same ideas, but a little bit different in that you're going to use a self-signed certificate, which isn't good for security purposes, but it's fine for our homework purposes and for educational purposes. You're not going to deploy your homework site to millions of users, right? If you do, get a domain name and get a legit cert. The only reason I don't require a legit cert is because you would have to, every single one of you would have to buy a domain name and go through that. And then I'm going to have a handful of you who already use your GitHub education license and would actually have to pay money for that domain name. I don't want to go through all that. I'm not going to make you pay money. Whereas as a group, at least one of you is going to have a free domain name available through GitHub Education. So that's the only reason this is a self-signed, is to avoid you having to spend money to take a course that you already spent money to take. Doesn't make sense. So for this, we're going to use Nginx, and we're going to spin up Nginx as a separate container using Docker Compose. So Docker Compose, you're running your app in your database right now. We're going to add a third one for Nginx, and then set up the Nginx configuration to listen on ports 80 and 443. If you get a request on port 80, it's HTTP, and just talk to your server. If you get a request on port 443, that's going to be HTTPS, and you're going to use your self-signed certificate to handle the encryption of that connection, which is going to be generating essentially those lines that CertBot generated for me. You're going to write lines like that that point to your self-signed cert and your generated private key. And then Nginx does the rest, honestly. Nginx does all the actual encryption. And then Nginx is going to forward that to your app, which is still just going to speak HTTP. Your app doesn't have to change, just like we talked about last week. Your app speaks HTTP. Nginx will speak HTTPS, decrypt, and then send the HTTP request to your server. And that's it. The last homework of the semester. And you all know what you have to do for your project, so everything's on the table now. You know everything that you have to do. One thing I forgot to mention last Friday about the open source reports, I get this question a lot, so I just want to make sure I say this during a lecture sometime. I mentioned that you have to show each path, like each link in the path from your code to code that looks like your homework code inside the library. Show me each path. This method calls this method, calls this method, calls this method, etc. For each one of those links, I want the actual URL for the code in GitHub. Like, where is that code? Give me a link to the line number, like here, this method right here, this is the code. And then like a sentence or two will suffice. You don't need to go into any great detail on the explanation of exactly how it works. Of course, more detail is fine. It'll be absolutely great if you go into more detail. But you don't need to give much detail on each one of the links. But each link, yeah, this called this, and now we're in this library. And this is where it's actually doing the thing. Like just a sentence or two for each link. The big thing that I want to know are the links. Like, did you actually dig through the library to see, actually physically see with your own eyes that path of how your code actually calls code inside the library and does the thing. That's the biggest thing that I'm worried about, but at least a sentence or two explaining each link, but no more than that is required. I don't need paragraphs on each one. This method will do this, and then 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 it calls this other one. Just say, yeah, this method is reading the bytes of the request, and then calling this other method, which is going to parse the headers. Something like that, it suffices. Whew, all right. Phone fell asleep. For homework 4, is it okay if we keep the max age? If we keep the max age every time we go to localhost 8080? Wait, what? Is it okay if we keep setting the max age every time we go to localhost 8080? Yes. Yep. Perfectly fine. What's max age, the rest of you say? Well, let's talk about it. So let's talk about cookies. Today's all about cookies. This is what we'll need. Those authentication tokens will be stored in cookies. So let's talk about what cookies even are before then. Like I said, I think if anybody wants to give feedback on this, what you think would be all right. I think this should go in homework 1 content even. And maybe the API stuff will get downplayed because homework 1's a little stuffed, especially in the fall when I lose Labor Day. I have one less lecture to work with. But I feel like cookies should be a lot earlier in the semester because it's not that complex of a topic. It's really just HTTP stuff. And I think it would get you all to parse your headers earlier because I'm still seeing like really janky code to read headers in office hours. It bugs me every single time. It doesn't bug me. I mean, code however you want. But when your code's buggy also, and it's because of the way you're parsing headers, that just drives me nuts. You ignored my advice, then came to me to fix your problem. That's caused because you ignored my advice. It drives me nuts. Anyway, not actually nuts. I'm still happy to help. But let's talk about this. So HTTP is stateless. Every time you get a request from your server, there's nothing in your code that says, okay, I got a request from this IP address, this port. Let me look up this user's information. Yeah, this user. Okay, they requested the HTML, so now they're probably going to need the CSS and the Java. You don't do any of that, right? You get a request for the HTML, you respond with the HTML. You get a request for the CSS, you respond with the CSS. You don't give a damn that there's somebody on the other side who's actually assembling the entire web page and requesting everything. If somebody just requests your JavaScript, your server's going to be more than happy to just fire off the JavaScript, and that's it. That's the way we code it, and that's because HTTP is stateless. That's the way it's designed. That's the way the protocol is designed. You get a request, you handle that request, you return a response, and that's it. You don't have any persistent connection or anything. You don't have the idea of users. None of that. None of that at all. But we want that, right? I want the idea, I want to be able to go to a site, log in, and then each request I send, that server remembers me and knows, oh, that request is from this person. Let me give their preferences. It looks like they want dark mode. I looked up my database, looked up their user preferences. They have dark mode set. Let me, send them dark mode CSS. Things like that. That's what we want. And we can't do that with just HTTP. HTTP says, nah. Stateless. No, we don't let you do that. So, of course, the answer is going to be cookies. We want cookies to be able to remember some information about a user, and then each time we get a request, the request itself is still stateless, but we have it in such a way that each request, we have just the content of that request. So we can only look at the content of that request to be able to handle it, but we're going to make sure the content of that request contains some information specific to that user. We're going to pull that information from the user, then go to our database, and based on part of the request, get specific information from the database, and then respond with specific information about that user to that user. That's what we want to do. And cookies are going to get us there. So cookies, remember, cookies are a way that we're going to tell the client to remember some information and send us that information back each time they send us a request. And this is all through HTTP headers. We're going to say, hey, remember this information. Through a header, The browser is going to read that header and say, oh, yeah, let me set this cookie and remember this information. And then whenever that browser is sending a message back to our server, sending a request back to our server, it's going to attach that cookie to all those requests. So we're telling the server, or we're telling the client, hey, send this back to me. Whenever you send me a message back, send me this information too, this thing that I'm sending you. Since it works through headers, ASCII only. Sorry, no non-ASCII characters in cookies at all. Not allowed. Because it's in HTTP headers, if you remember, the headers are strictly ASCII only text. This is to make them compatible. There are a lot of restrictions with headers. So this and the size, I guess. I shouldn't say a lot. This and the size of headers. We have these restrictions to make sure that everything is compatible over HTTP, over the internet. If not, your HTTP parsing code would look a lot different. Because right now, because of our restrictions, you have, in this class at least, the assumption that the first read from the TCP socket will have all of the headers of that request. And that we get away with that because the total size of the headers is restricted. You can't have just infinite amount of bytes in the headers. So that first /r/n/r/n has to appear in, I think the usual limit's like 4K, but it's different on different implementations. Different browsers, different servers, it's enforced browser side and server side, will have different limitations. But it's on the order of a couple K is going to be the minimum of any implementations. If you stay below 2K and you read 2K from your TCP socket, you usually be all right with that one. So the size, and then you have to parse them. You don't know anything about the request before you start parsing the headers of the request, especially the request line. Whereas like the body of the request might contain an image, so you can't just start parsing that because you don't know if there's an image or not. But you can parse everything before the body because it's ASCII only. So this is an important restriction. I mean, it could be UTF-8 these days, but for backward compatibility purposes, we can't quite make that change. We would break a lot of stuff on the internet if we just said, hey, y'all can use UTF-8 now. A lot of things would break. A lot of old servers who are hard-coded to ASCII. So it's a hard change to make. But anyway, at the very least, they would have to stay text only, so you can decode the headers and then start parsing the headers. So we do have this restriction. ASCII only. So ASCII only cookies. Our two headers of relevance for cookies are set cookie and cookie. Set cookie, that's the one we're going to use. When we're sending a response to a user and we say, want them to set a cookie, we're going to use the set cookie header. I don't have a lot to say about that. We're going to use the set cookie header. That's going to be our way of saying, hey, client, whenever you send me another request, please send me this cookie back. I would like this information back every time you send me a request. And then cookie, when the client sends us a request, that's going to contain every cookie that was set. Every cookie that client is remembering is going to be sent on the cookie header. So, syntax, the set cookie header is going to use this syntax. Cookies are key value pairs using an equal sign. So our set cookie header, just like that. We want to set a cookie of visits. Visits equals 4. This is why this stuff belongs in homework 1. By homework 4, y'all are so beyond just the syntax of HTTP requests. But if there are questions, let me know, and I can slow down a little more. But if we want to set cookie as a header, and then a key value pair, name of the cookie, value of the cookie. So I'm setting a cookie named visits with the value 4, a cookie named ID with this value of some ID. You can only set one cookie. I have this on a slide. Is it? Yeah. You can only set one cookie per header. If you use the set cookie header, you can only set one single cookie. So what happens when you want to set two cookies? We're going to have cases where somebody's logging in, and we want to set their auth token cookie, and we want to increment their visits cookie. We have to set both of those. No problem. We're just going to send 2 headers. So we're going to send 2 headers, both of the value set cookie, which is actually allowed. So we can send duplicate headers with the same name. We can send 2 set cookie headers. So what we saw in the previous slide, if these 2 headers were on the same response, that's 100% valid. So whenever I say write your general header parsing code and throw all your headers in a key value store, it's a little bit slightly inaccurate. It never comes up in this course, which is why we get away with that. But technically, the client could send you 2 headers with the same name. And if you're storing them in a key value pair, you will overwrite the first one that you parse. So technically, this is allowed by HTTP. You can have multiple headers with the same name. And we will actually use that when we're sending responses to the client. But that'll never be the case when the client's sending messages to us in 3.12 for anything, any part of the homeworks in 3.12. And personally, I've never seen it. I've never seen a request where there were 2 headers with the same name, though I've seen many responses, of course, like on screen. It's plenty of responses where you have multiple headers with the same name, especially when multiple cookies are being set. You can open up, speaking of incognito windows, you can open up an incognito window and go to like pretty much any website, and that first request response, that response is going to have, hey, you don't have any of my tracking cookies. Here, set all of these. And your browser is going to set those cookies or not. But you'll see a request with multiple set cookie headers. But wait, the client's got to send us all those cookies back, right? Aren't they going to send those in multiple headers? You should be wondering. No, the cookie header, this is when the cookies are being sent back to our server from the client. And this is a semicolon delimited list of cookies where each cookie is key value pair. So when the cookies are sent back to us, it's just one single header with all cookies in that single header. So we don't have the same problem when the cookies are coming back to us. It's just cookie, which I always, every time I get to these slides, I'm like, do I have a typo here? I feel like it should be cookies, but it's cookie, singular, even though it can have any number of cookies. And very often has more than one cookie. It's very rare a website uses exactly one cookie. But I'm not in charge of naming things, so it's cookie, not cookies. Yeah. I never thought about that, but I think it does, yeah. So the question, does that mean our cookies can never have the semicolon character? I would have to assume it does. I never really thought about that, though. If cookies have a way of escaping semicolons, I don't think they do. I think that's just a restricted character. Right? It'd have to be. It doesn't have to be. It could be like surrounded by quotes to say that this contains some escaped characters, but then we got to escape the quote. It's the same issue with CSV. If we have commas in our data, I mean, we could do the same thing. I don't know what is actually done, to be honest. Try it and let me know. Set a cookie with a semicolon. Yeah, I never tried it. It would definitely break your parsing code if you're splitting on semicolons. So the idea of parsing this, you get the cookie header, you split on semicolon, and for each value, make sure you trim them. This has been a common mistake, issue, office hour question, Piazza question. In homework 3 with the WebSocket handshake, make sure you're trimming white space, please. Trim your white space. How many students, which is like 2, but 2 that came to me, so I assume the TAs have handled quite a few more cases of this, where you're reading the key, the WebSocket key during the handshake, and then computing the accept, and then sending it back, and you just get the finished and nothing works, and you don't get a successful handshake. Because there's the white space, specifically this white space right here, students are leaving that in and then computing the accept with that white space in addition to the key, and then getting the wrong accept. So make sure you're trimming white space when you're doing this, but split the cookie on semicolons, trim white space, then split each one on equal sign. So I guess each value couldn't have an equal sign either. There has to be some restricted characters here. And then get your cookies as key value pairs and put those in a nice dictionary would be nice. Did I read it? I just looked at this message, but then I didn't read it. What am I doing? Is it expected for HTTP only and max age to only show in response headers, not request headers? I don't see either when I refresh my page, but when I make a request, I see it in the response headers. Yes. Was that the question? Is it expected? Yes, that's expected. So the reason why this can just be in one header is because it is strictly key value pairs, period, done. Any other information associated with these cookies is not sent on requests, but there is extra information that we can send on responses. We can set any number of directives attached to a cookie that we're setting. So when we're sending a response, we're going to set all these directives, which is why we have separate headers if we set multiple cookies. Instead of using the same syntax as when the client's sending us cookies, why not just put all the set cookies on the same line, semicolon, separated? Well, it's because we're allowed to have directives when we're setting a cookie. So set cookie sends a single cookie with any number of directives. When the client is making a request and we're getting the cookies, it's any number of cookies, and it's strictly name value, name value, name value, name value. The directives will be remembered by the browser. And if you look at your cookies in the browser, you can see what directives are set and what all the directives are, but you won't see those in HTTP at all from the client. They're only seen when we're setting them from the server, when we're using set cookie. Good question. But that's exactly why set cookie, multiple headers per cookie, but cookie, all cookies in one header. It's that question is exactly the reason. So directives separated by semicolons, and let's talk about what these directives are. So there's only a handful of these, only 3, right? Depends how you count them, 3 or 4. I count expires and max age as the same one. But expires, give me the, forgot the format of this. UFT? I don't know. I don't remember. I should have put it on this slide. But this format, this exact format of when the cookie should expire. So day, the 3-character day name, comma, the numeric day, you can go through the whole thing. But specify in exactly this format, which is a common format. You can create a date Python object and say to UTC, Universal Time something. UTF is the other thing. But anyway, in this format, you don't have to manually do it, but each library will have some way to generate strings in this format. And that cookie will expire on at that exact second in time. So this is enforced and stored by the browser. So when you set a cookie like this, the browser will remember when that cookie is supposed to expire, and it's always going to send that cookie in request to that server as long as the cookie isn't expired, and as soon as we pass this date stamp, this timestamp, it's just going to stop sending that cookie. That cookie will expire, so it won't send it to your browser anymore. Your browser will see that there's no cookie there, and your browser will do whatever it's supposed to do, whatever you coded it to do in that case. Set a new cookie probably is what it's going to do. But expires is cumbersome, I'll say. On the much better side of things, max age, usually more of what we're interested in, is setting an amount of seconds after which the cookie should expire. Which if you're using max age, a lot of times you're probably going to, if you're using expires, you would probably be doing some math to take some max age and then compute the expires. Let's just use max age instead, right? So max age, number of seconds after which the cookie should expire. So if I do max age of 3600, that should be 1 hour. Any request made in the next hour, the browser is going to send this cookie to me. After 1 hour, the browser's not going to send that cookie back to me anymore. So I'm saying, hey, browser, send this cookie back to me in every request for the next hour. And a question earlier in chat was, if every time I get a request, if I reset the max age, that's perfectly fine. You don't have to keep track of like how old is this cookie or anything, none of that. So for like the visit counting cookie, if somebody hits refresh, they send you the visit cookie, you're going to read that cookie, increment it by 1, and then reset the cookie, and that can reset the max age clock. That's what I would expect you to do for learning objective 1. Whenever you get the cookie, you read cookies. If there's no visit counting cookie at all, set it to the value 1, presumably, and use a visit of 1. If it does exist, parse the cookie, read the value as an integer, increment it by 1, send that to your HTML template and whatever you're doing on that end, and then fire off the set cookie, the response with a set cookie of the new value and a max age of probably 3600 again. In the homework I said it should expire in an hour if you just use 3600 for your visit counting cookies. Perfectly fine. Universal time coordinated. Hey, I did have the right acronym in one of my guesses. I gave it enough guesses. Blame the French according to Ethan. Yeah, universal time coordinated. That's. Can I just call it UT, universal time, or UT? Yeah, I can't call it UTF. I want to call it universal time format, but that gets confusing with UTF. Well, yeah. What's a session cookie? You're ready for the next slide. Get moving, Jesse. You're getting sidetracked. So if you have neither of these, no expires or max age, then your cookie is going to be a session cookie. So expires and max age tell the browser, hey, this is when the cookie should expire. Stop sending it to me after that. If you don't set either of those, you get a session cookie, which means once that session ends, you're going to lose that cookie. The browser is going to delete that cookie and say, okay, I'm not going to send it during the next session, but as long as the user keeps the browser open, and note browser, not tab, the entire browser window open, as long as that window stays open, that cookie stays active. So if somebody never closes their browser, like me, I never close my browser windows, I just close tabs, and that cookie is going to last a while. If somebody closes their browser every day or every hour or constantly, then that cookie is not going to last too long. But the important part is we, from the server side, the back-end side, have very little control over how long this cookie lasts. So usually we're not going to set session cookies on the server side unless we have a very specific use case for that. Of course, it's a tool in our toolbox. But usually we want more control over the cookies than that. The secure directive. Yeah. I don't know. I don't have an exact answer for you on that one. That is in general through programming, that's a strong source of bugs. I don't know exactly how the browser handles like time zones and the like. If you set a cookie that expires in an hour and then we have the spring forward, we set our clocks forward, does that cookie last like 1 second? I don't know. It's going to be up to each browser implementation to some degree. What they should do, especially if you're using expires on, that could get awkward. If you want to set a cookie for an hour and you use expires and you do the math and have it expire in an hour and then you have the spring forward at that moment, you're going to have a very obscure bug that's really hard to debug, which does happen. Those things are painful. That's why we like using the epic timestamps, because that is just definitive. Like at this moment after January 1st, midnight January 1st, 1970. That's why we like using that so much instead of actual times and stuff. But yeah, and another reason why I would use max age instead of expires, because I'll have fewer of those bugs. Things break a lot on that stuff. Times are complex, especially you have like a leap year or something. Leap years, leap seconds. There's a lot of complexity to time. Somebody traveling across time zones, somebody going to, I just forget the state, but the state that doesn't observe daylight savings time. There's just so many weird edge cases that have to be handled. If somebody's one that doesn't really come up, but somebody's on either the North or South Pole, like they could be jumping time zones very, very rapidly. and that'll really confuse you. You're using time zone based on GPS. Things get confused really quick. The abbreviation comes from the result of ITU. Yeah, and I don't have, there's no clear answer to what the acronym should be, so I guess I'll accept that there was a big debate, and that's what we landed on. I'll go with that. And I'll just use max age to avoid it. The secure directive means, hey, browser, only send this cookie over HTTPS. If you're sending an HTTP request, don't send this cookie. And that's just the word secure. There's no key value pair here, just the word secure. And that's it. I don't have anything else to say about that one. HTTP only means only send this cookie over HTTP or HTTPS. I guess given the secure directive, that one can be a little misleading. But only over a request to the server. So you can go into your browser and view all your cookies. And in the console, you can view all your cookies, including HTTP-only cookies. But in JavaScript, in the actual console, you can run document.cookies. It's a variable that that'll display all your cookies. So you do document.cookies, it'll show you all of your cookies. So if somebody sends an attack, somebody gets an attack script and gets some JavaScript running on your machine that grabs your document.cookies and then sends off an AJAX request to their server, it'd be a pretty simple way for them to grab all of your cookies. If they can get any JavaScript running on your machine, it'd have to be in that domain, on that site, I guess. So it's still tricky. But they can grab all your cookies for a site, read document.cookie, fire off an AJAX request to their server, they have your cookies. So HTTP only, this directive, won't display your cookies in document.cookies. You can only see your cookies either in the browser console, which somebody has to have physical access to your machine. At that point, you're screwed anyway in so many ways. Or they have to be able to see the HTTP request and see the actual cookie header to read your cookies. The cookies will still be set in the cookie header, because that's the whole purpose of cookies, is we want to see the cookies on the server side. But the attacker, through JavaScript, won't be able to read these cookies if they're HTTP only. Path, this one, I think way less useful. I've never found a good use case for this one. But path, if you set some prefix, this cookie will only be sent on paths matching that prefix to your server, of course, but only on things that match that prefix. So if you only want a cookie sent on certain requests, then you can set the path directive. This isn't really a security thing, though, unless, I don't know, you have different teams handling requests from different paths, I guess. I don't know. So it's not really a security thing. I guess it's just a clutter thing to limit the number of cookies that are being sent around. But I don't know. I've never found a good use for this in terms of security or privacy. Usually I'm controlling the server, or somebody is controlling the whole server. Anybody with access to some of it has access to all of it. And then SameSite. But for what it's worth, I'm doing a comprehensive list of directives, so I had to include that one. And then SameSite. SameSite has 3 different values it can have: lax, strict, and none. Lax is the default. This is when your cookies are sent on third-party requests. So if somebody's visiting my page and I have an embedded. I guess we do music here. I'll just, if I have an embedded Spotify link, where's this example going? Say I have an embedded Spotify player on CSE312.com, and you can see what song is currently playing or what song is going to play at the end of lecture, and that has to talk to Spotify. It's going to send AJAX requests to Spotify to get that information. So you're visiting CSE312.com, and as CSE312.com as the origin, you're going to send requests to Spotify.com. So I don't want all of my CSE312 doesn't use cookies, so it's not the best example. But I don't want all my cookies being sent to Spotify when you make that request. So SameSite is going to give you some control over when your cookies are sent on these third-party requests. If you do strict, They're not going to be sent ever. They're only going to be sent when the origin matches the URL, the server for the request. So only when I'm visiting cc312.com and sending requests to cc312.com, which should be all of the requests on 312. But if you go to a site, you'll see a lot of third-party requests. There are all kinds of APIs that are being accessed, all kinds of tracking stuff. Try to go to any major site and just look at how many different hosts you're making AJAX requests to. It's a lot. Most of them are going to be the big names, the Googles, Amazon, Facebook. They're all tracking you pretty much wherever you go. So this controls how much you want of that. None means the cookies are always sent every single time. If you set none, it has to be secure. You have to also use the secure directive, so not literally everybody can see your cookies. And then laxes are kind of in between. This is when somebody's navigating to your site. So if I have a link to Spotify, you click the link, so you're actually going to Spotify. Spotify is going to get those cookies when you're heading over there. Yeah. Never. So at what point do you have to ask the user if you can store cookies? Never, but there is a law in Europe where you are supposed to ask them. So that's why you see sites constantly asking. It's because they're being European compliant. In the U.S., we have no such law. And, according to the protocols and everything, aside from like legal matters, there's no technical reason to ever have to ask a user to set cookies. That's European lawmakers being completely paranoid and honestly not understanding how the internet works. Either that or they're actually concerned about tracking and things like that. Because you are being tracked with cookies all the time. I think they went overboard on that, in my opinion, at least. And for what it's worth, you can set cookies client-side. I only have this slide because if you've used cookies before, this might have been how you've done it. In CC 199, if you set cookies, you set them client-side. So you can go into your client-side JavaScript and set your own cookies. You have full control over your own cookies as a client. You can go to the console, modify any of them, delete them, do whatever you want with them. They're your cookies. You do what you want with them. So you can set them client-side. So be careful. Cookies should always be validated, verified, secure, because the client has full control over them. I'm out of slides. Perfect timing. Why don't headers have a more standard format? Seems like they keep adding random stuff. It's pretty standard. It's fairly standard. I mean, most headers have like a semicolon separated list of things. Like they're fairly standard. Not completely, but fairly standard.